My name's Mark Megson. I'm Vice President at AppLabs. I've been working with the company for about 5 years. During that time, the evolution of IT and the progress that the industry has made has been absolutely fantastic. But also, given in the backdrop of all of that technology advance, there have been some casualties, the biggest of which is probably the environment. Sort of in view of this, the last few years have seen a mind shift by organisations as to responsibility towards the environment, and AppLabs take a sustainable IT very seriously, and we've got various initiatives in place to reduce our impact on the environment, as I'm sure many of your companies will have. But where we sort of see opportunities to reduce the environmental impact of testing, we really wanted to sort of share and run this webinar around this topic. My colleague John Brennan has researched this extensively and has put together an informative and entertaining webinar on it. So I'll pass over to John. He's going to highlight some of the areas that you can hopefully make a difference in, and pass on to your colleagues. And if you ask any questions on this, either sort of input through the chat box, or alternatively at the end of the presentation, John will give you an email address to follow up with. So without further ado, over to John.
Thanks, Mark, and welcome to everyone attending today's webinar entitled Environmentally Aware Testing and How Efficient Your Testing Practices. During today's presentation, we will look at the following areas: the future of software testing realities, environmental impact, a real-world example, a revised testing approach, evolving roles and responsibilities, and finishing off with reasons to go green. As we're all aware, the testing industry and associated processes evolve in reaction to a variety of factors, such as market sector changes, such as regulatory body changes and mandated audit change, government and political change in the company's home country, Europe, or even worldwide, business environment changes such as those witnessed by the credit crunch, which has imposed strict budget constraints on a wide range of project initiatives, and in some cases organisations are reviewing the testing methodology in place and looking at alternatives, or in some cases adopting at the very least some sort of framework. There are other contributing factors that impact testing services. However, those mentioned certainly play a pivotal role. But now from a testing perspective, what is it that we're actually looking to achieve? Well, we're looking at reducing risk to the business, verifying that the delivered system or product meets the needs of the business and achieves what was set out in the requirement specification. We're also looking to gain confidence in the proposed system or product, and of course to unearth defects before go live. However, what about global environmental considerations? In many testing projects, development lifecycle milestones and associated toll gates are planned at the project outset, and as time goes on, concerns over the legitimacy of the original requirements, the understanding of those requirements, the development phases, and even the IT environment delays ultimately lead to testing being squeezed. This is particularly true in regulatory-driven projects, and this presents a number of concerns to the functional and non-functional risks of the project, such as those mentioned in the slide, for example security concerns, functionality failure, performance and load issues. In some instances, project go live dates can actually move, particularly when it is clear that the expected deliverable is still far from ready or even fit for purpose. This, however, presents its own challenges, such as loss of competitive advantage through missed market opportunity. Testing projects then begin to stack up, and parallel testing results in increased IT infrastructure resources. And as a consequence, ineffective or inefficient testing results in resource wastage and ultimately global impact. Let's now look at some examples of the impact the previously mentioned problems can now have on the environment. During a large testing program, a large number of client machines will typically be used to develop and test the expected deliverable. For example, 1,000 PCs running 24/7 without energy saving modes activated can equate to as much as £70,000 worth of electricity in a year, according to Global Action Plan. Gartner estimate that PCs and monitors account for 40% of the global IT device carbon emissions, which is nearly double that of the data centre. And each year, enterprises waste nearly $4 billion powering devices that are not even in use. Performance testing will play an important role, highlighting packet sizes and how much traffic makes its way across local and wide area networks. Local and remote caching will play a critical role here to ensure that performance is optimized, which also brings with it an improved end-user experience. This, however, also brings about energy and ultimately environmental savings. From a data center perspective, 50% of the energy costs equate to the actual power for machinery, with those energy costs expected to exceed the original acquisition cost. The remaining 50% of the energy costs are then attributable to the air conditioning and UPS. In the UK, we utilise energy in the region of 1.15 billion kilowatt hours per year to power IT equipment, whereas in the States this equates to in excess of 50 billion kilowatt hours, or 1.5% of the total US electricity consumption, equivalent to the consumption used by approximately 5.8 million American households. Data storage is growing at an alarming rate, leading to vast infrastructure requirements. It is estimated that 35% of all application data is duplicated, according to Forrester. Therefore, it is vitally important that we understand what technology is required to support our project commitments and testing phases, and then direct those resources accordingly. There are technical solutions to help reduce environmental impact, such as multi-core processing, which can increase 64-bit application performance, reduces IT cooling and energy use, all while increasing system utilization through application consolidation. Some systems may be I/O, CPU, or memory intensive, and virtualization can aid in this regard. The objective, however, is to understand which virtual workloads can be combined in physical systems without causing resource constraints, with gains estimated at 70 to 80%, with return on investment in as little as 3 to 6 months. Again, virtualization offers reduced energy consumption and wastage through reduced hardware requirement and greater utilization of what is actually required. Either approach or any other technical solution will dictate the chosen testing strategy, as each solution brings with it its own challenges. It is therefore important to have appropriately skilled testing professionals to support the chosen solution.